Okay, section 4.8, the remainder and factor theorem. The remainder theorem. Actually, before I explain the remainder theorem, I want to do two things. I want to do these two problems here. All right, so let's, I want to do this division problem. So I'm going to divide this polynomial, which is a quadratic, by x minus 3. And then I'm going to find what f of 3 is. So if I'm going to divide this by x minus 3, I'm going to use synthetic division. I'm going to put 3 in the little box. I'm going to put negative 3, 5, and 4 across the top. I'm going to bring down the negative 3. 3 times negative 3 is negative 9. Add them up, that's negative 4. 3 times negative 4 is negative 12. Add them up, I get negative 8. Okay, nothing interesting yet. Now let's figure out what f of 3 is. F of 3 means everywhere you see an x, you're going to put 3. So I've got negative 3 times 3 squared plus 5 times 3 plus 4. Do that in your calculator real quick. Negative 3 times 3 squared plus 3 times 5, which is 15, plus 4, and you get negative 8. Interesting. They turn out to be the same thing. And it turns out that that is a specific example of what's called the remainder theorem. The remainder theorem says this: if you divide a polynomial by a binomial that's in this form, then the remainder is going to be the same as if you found f of a. So in other words, if we divide this quadratic by x minus 3, we'll get the same answer as if we find f of 3. Now the reason for that is sort of interesting, and we can show it graphically pretty easily. It has to do with if x minus 3 is a factor, then 3 has to be a 0. And if it's not a factor, then the remainder still has to be consistent. But we're not going to really dig into why that is in this video. So let's look at this example here where we're going to use this leads into what's called synthetic substitution. So if I want to find f of 4, for example, in number 1 here, I don't need to plug in 4 and use my calculator and all of that. I can use what's called synthetic substitution to do it. And all that is synthetic division. It looks the same as synthetic division, but we're asking and answering a different problem. We're asking a different question. All right, so what I'm going to do then is, in this case, I'm just going to take the 4. Notice over here when I was trying to find f of 3, the factor that I was dividing by, it was connected to, was x minus 3. But I took whatever was in the function value to plug it in. Do the same thing here. So I'll put in 4 here. I'm going to put 3. And then we have to be careful here. So we got 3, negative 2. There's no squared term. So I'm going to put a 0 as a stand-in for the squared term. And then 5, and then 2. Here we go. 3, 4 times 3 is 12. Add them up, that's 10. 4 times 10 is 40, plus 0. Add them up, that's 40. 4 times 40 is 160. Add them up, that's 165. And then 4 times 165, I don't remember. So 4 times 165 is 660. Add them up, I get 662. All right, so you can see that that's a lot faster. And so instead of plugging in 4 and plugging in your calculator, that's pretty quick. So anyway, f of 4 then has to be 662. That's it. Okay, so that's one concept. Let's jump to the next concept. We're going to lead into it again. It's called the factor theorem, but I want to lead into it with these two problems first. How do you know if 12 is a factor of 60? Think about that for a second. How do you know that a number is a factor of another number? Well, the easiest way to figure that out is, probably to check your factor sheet, but the other way, that's slightly longer, but also not that hard, is to take 60 and divide by 12, divide 12 into it, and see if you get a remainder of 0. Okay, so if you take 60 and you divide it by 12, 12 doesn't go into 6, it goes into 65 times, 5 times 12 is 60, and you get a remainder of 0. So that's how we know that 12 is a factor of 60. Over here, how do you know if x plus 3 is a factor of x squared plus 7x plus 12? Well, you take and you divide it, and you see if you get a remainder of 0. Let's do that real quick. Negative 3 in the box. 1, 7, 12. Bring down the 1. Negative 3 times 1 is negative 3. 4. Negative 3 times 12 is negative 12. 0. Remainder of 0. Okay, so x plus 3 is a factor of x squared plus 7x plus 12 for the same reason that 12 is a factor of 60. That leads into the factor theorem. The factor theorem says this: if you divide a polynomial by another polynomial, like we did over here, and the remainder is 0, then the second polynomial is a factor, okay? So if we're asked a question that is like number 2, determine whether x minus 5 is a factor of x cubed minus 7x squared plus 7x plus 15, we'll do synthetic division, and we'll see if it is, all right? So I'm going to put 5 in the little box. Coefficients across the top, 1, -7, 7, and 15. Should have given you guys more space, I apologize. So bring down the 1, 5 times 1 is 5, add them up, that's -2. 5 times -2 is -10, add them up, that's -3. 5 times -3, -15, and I get 0. So this one is, yes, it is a factor, okay? All right, so if I am trying to answer the next question, which is given the polynomial and one of its factors, find the remaining factors. Think back to numbers. If I gave you a question like this and I said, all right, well, you know, here's 100 and 2 is a factor. Can you find the remaining factors? You probably could, right? You take 100, divide it by 2, and you get 50. And then you'd be like, all right, well, what are the remaining factors? Well, there's another factor of 2 because 50 is divided by 2. And then you could keep going. In fact, that was our breakdown process. We put 100 in the box. We take 2, 50, and we get all the factors in this way, right? 5, 5, 5, 1. This would be all of our factors. So we would take that first number that we know is a factor, divide it out, and then look for another factor, divide it out, and so on, okay? So the same process is going to be true for polynomials. If I know that x minus 2 is a factor, I will divide it out of here and then continue to factor the rest of the way. All right, let's look at number 3. Number 3, given the polynomial, one of its factors, find the remaining factors. So our goal here is going to be to take the factor that we have, divide it out, and find the other factors just like we did over here with the numbers, okay? There's a typo, however. Yours says x minus 2, and I found out that it actually should be x minus 3 after I tried to solve this once. So I'm going to put 3 in the box, and I'm going to do the division to divide out x minus 3. So 3 goes there, 1, -7, 7, and 15. All of the degrees of the powers are accounted for. So here we go. I'm going to bring down the 1. 3 times 1 is 3. Sorry. That's going to be -4 when I add them up. 3 times -4 is -12. Add them up. That's -5. 3 times -5 is -15. And I get a remainder of 0. If you don't get a remainder of 0 here, something went wrong because you were supposed to have been given a factor, which means the remainder will be 0. So I'm left with then this, x squared minus 4, x minus 5. All right. Now, I want to find the factors of this. This is a quadratic, okay? So what we can do is we can do the magic x to figure it out. So the magic x, remember I put a times c up here, so that's -5 up here. I put b down here. I need numbers that multiply to give me -5 and combine to give me -4. So 5 and 1 are my only options. Put the negative on the 5. So then I know that I've got to go -5 here and 1 here. So this must break into x minus 5 and x plus 1. All right, and so since that breaks into x minus 5 and x plus 1, those are my other factors. So all the factors then of this polynomial, just to make this 100% clear, this polynomial right here, x cubed minus 7x squared plus 7x plus 15, whoa, plus 15 is equal to x minus 3, x plus, x minus 5, and x plus 1, okay? So we've completely factored this polynomial in this way. So if you're given a factor, what you do is you divide it out, and then you factor it either using what you know about how to factor quadratics or any other factoring rule that is relevant. Difference of cubes, sum of cubes, quadratic form, or difference of squares are the ones that we've talked about. Okay, and that's pretty much it for section 4.8. It's the remainder and factor theorem, a lot of stuff that builds on those two things.